A first ever 3D simulation of a jet formed by a collapsing star explains what's behind blinking gamma ray bursts. You're looking at that video right now. That's the latest in a report at Space Chatter. Hi there, I'm Jeff Allen. Please like and subscribe to get all of the latest breaking space stuff directly to you. Now, astrophysicists from Northwestern University have developed an innovative simulation of an entire evolution of a jet formed by a collapsing star, or what's called a collapsar. It's the first ever full 3D simulation of the jet's evolution from its birth near the black hole to its emission after escaping from the collapsar. The jets generate gamma ray bursts, which are the most energetic and luminous events in the universe since the Big Bang. And researchers say the new simulation shows these gamma ray bursts are 10 times rarer than previously thought. Assistant Professor of Physics and Astronomy at Northwestern Weinberg College of Arts and Sciences, Or Gottlieb, said, quote, "Previous studies have tried to understand how they work, but those studies were limited by computational power and had to include many assumptions. We were able to model the entire evolution of the jet from the very beginning, from its birth by a black hole, without assuming anything about the jet's structure. We followed the jet from the black hole all the way to the emission site and found processes that have been overlooked in previous studies. Gamma ray bursts emerge when a massive star's core collapses under its own gravity to form a black hole. The jet launches into the collapsing star after energizing when gas falls into the rotating black hole. The jet then generates a bright gamma ray burst after breaking free from the star. Gottlieb said the jet generates a gamma ray burst when it reaches about 30 times the size of the star, or 1,000,000 times the size of the black hole. Now, he made this comparison. In other words, if the black hole is the size of a beach ball, the jet needs to expand over the entire size of France before it can produce a gamma ray burst. Gottlieb's simulation showed something different than previous studies. The jet's disk tilts when falling material from the star falls onto it. The jet then wobbles inside the collapsing star as it struggles to realign with its original trajectory. The wobbling causes gamma ray bursts to blink since the jet moves in and out of the Earth's telescope's field of view. So it's a perception issue for us. Previous studies predicted that about 1% of collapsing stars produce gamma ray bursts, but Gottlieb believes it's much rarer than that. But Gottlieb also believes gamma ray bursts are 10 times more observable than previously thought, meaning astrophysicists are missing a lot of them. Gottlieb says most of the jets either fail to be launched at all or never succeed in escaping from the collapsar to produce a gamma ray burst. However, they remain buried inside. You can check out more info on this and other cool space news and updates by clicking the link in the description below and head over to spacechatter.com.